So today we're continuing with assigning oxidation numbers. All right, we started it yesterday just to get a brief look at it, but we're going to go into details today's class. So remember we said, so the definition for oxidation and reduction, right? They looked at gaining of oxygen versus loss of oxygen. So gain of oxygen was termed oxidation. Then they looked at it in terms of hydrogen, losing and gaining hydrogen. Realizing that it was limited, it was then modified to looking at loss and gain of electrons. Now, depending on the type of reaction, you may not necessarily readily pick up loss and gain of electrons. So another definition was looking at increasing oxidation and decreasing oxidation numbers, right? So remember, when you talk about loss and gain of electrons, you're really speaking towards an ionic bond. So you're looking at the formation of ionic compounds, but not all compounds are ionic. You do have covalent compounds and they do not lose or gain electrons. So this definition of loss or gain cannot be a standalone definition, ladies. So it was modified to look at increase in oxidation and oxidation number, increase or decrease. So what was oxidation number? Let's just remind ourselves. What was the oxidation number? Anyone remembers? So your oxidation number pretty much is the number of electrons that would have been lost or gained had it had the species or the element entered into an ionic bond. So they're looking at the possibility to say, okay, if it were to bond ionically, how many electrons would have been lost or gained? So it's a hypothetical situation. It's not in actuality, right? Because again, you do have those nonmetals that enter into covalent bonds and they're not losing or gaining electrons. So our oxidation numbers, there are rules governing the oxidation, assigning the oxidation numbers to elements, right? So you have about 7 rules here, but I'm not going to look on it in this sense. How we're going to approach it today is to actually use a worksheet to practice the rules. So we have quite a number of oxidation numbers to work out, and we have the rules above them. So let's examine the rules. The first rule says that pure elements have an oxidation number of 0. Why is it 0, ladies? Because remember, your oxidation number is assumed when it has entered into your ionic bond. Very good. Now, if it is
so,
not,
Mrs. Daconis says the uncombined.
Right, very good. So that's uncombined. So if it's not combining with anything, it's not going to lose or gain. And so the number is 0. Lost none, gained none. So 0. All right. The next rule says that if the compound in an ionic compound, well, it shouldn't be compound. So if the element in an ionic compound, right, or if the compound is an ionic compound, then the oxidation number is the same as the charge on the ion. So let me say it again. If the compound is an ionic compound, then the oxidation number is the same thing as the charge on the ions, ladies. So what does that mean? We looked yesterday at magnesium chloride. When we looked at the charges, we noticed that magnesium had a 2+, chlorine had a single minus charge. So what they're saying is that my ionic compound magnesium chloride, the oxidation numbers for each element would have been equivalent to the charge. So magnesium would have an oxidation number of plus 2, and chlorine will have an oxidation number of minus 1. So if they're ionic, all you have to do is just remember the charges, and your oxidation numbers are synonymous to it. Number 3, if the oxidation number of hydrogen in a compound is plus 1. Now, the only exception to this is if it is in a metal hydride. So if it's bonded to a metal, so say for example, you have sodium hydride, then the oxidation number of hydrogen is minus 1. The oxidation number of oxygen is minus 2. The only exception is where you have peroxides. All right, then your number is minus 1. The sum of the oxidation numbers in a compound is 0. The sum of the oxidation numbers in a compound is 0. What does sum mean? It means that you're adding up. So a compound has elements A and B. When I add the oxidation numbers of A and B, it should be 0. Now, why is that so? It is so because elements carry no charges. Remember that we balance out the charges, when you're writing formula. So if I have 2 positive charges, I ensure that I have 2 negative charges. Those charges cancel out each other. And so my overall charge on the compound is 0. So the oxidation numbers for a compound is 0. The oxidation numbers in a polyatomic ion. What is a polyatomic ion? Again, we know some of them. So we have nitrate, we have sulfate, right? And the list goes on. Now, what they're saying is that when I add the oxidation numbers of the elements in a polyatomic ion, so if I add it for nitrogen and add it for the number of atoms of oxygen, it is going to be equal to the charge on the ion. So nitrogen oxidation number plus the 3 oxygens, the oxidation numbers for the 3 oxygens, when I add them up, I am going to get minus 1. For sulfate ion, the oxidation number for sulfur added to 4 of the oxidation numbers for oxygen will give me a negative 2 when added. That is what it means. So let us get to practice. I'm going to clear
Miss,
this screen. Yes?
wait, Miss, why you clear? Miss, put it back. That's what I want to ask you about.
You can ask still.
Miss, but, all right, Miss. Miss, so what I realized, Miss, I said that the element by itself is 0, right? Miss, when you have like, yes, Miss, put that there. Miss, when you have like, yes, Miss, that is 0, and Miss, you say O2 is 1 compound, right? Oxygen, right?
O2, which
Yes,
is this one, yes.
is 1, so that means that is 0, Miss. So like how you have 2 of them, Miss, that's where the 2 at the top come from.
For the sulfate,
Miss, for the entire element, Miss, and you put it together. Miss, understand what I mean?
I get what you're saying, but no, this has to do with how the atoms are bonded.
Okay, Miss.
Right. At your stage, you don't go into that details of how polyatomic ions actually, how the bonding is. You just learn about your ionic, covalent, and metallic. So you have other types of bonding where you have, I just want to mention the names. So you have something called dative covalent bonding, which is different. You don't learn that until you get to 6th form. All right.
Okay, Miss.
All right, so don't bog down your head with that just yet. When you get to 6th form, then you get the explanation of how polyatomic ions, why is it that they have a charge? All right, so I am going to split view, ladies. All right, so you should be seeing, no, don't do that. Come back over. All right, so this is a worksheet. So they're asking you for the oxidation numbers for each element. And they've given you the compound to your extreme left on your screen, and they're asking you for each of them. Now, what I like about this is that they give you the rule that we are going to examine and see how we're going to use it. All right. So there are instances where we may need to go pen and paper and work out some stuff. There are other instances based on the rule, we can just write it. That's a good thing about learning the rules. So our first compound that we have is, oh no, not green. What is SN, by the way, ladies?
Um,
Has nothing to do with the English name. All right, so SN is tin. All right,
oh,
right. So normally they call this tin. No, I shouldn't say the answer because it will give you the name. All right, so if I say the name, it's gonna give you the oxidation numbers. So right now it is tin bonded to 4 atoms of chlorine. Now what you need to do, ladies, this one has to do with rule 2. So we're going to go back to rule 2. Rule 2 says that if the compound is an ionic compound, the oxidation numbers of each element is the same as the ion's charge. It's the same as the charge on the ion. So right away, you know that this SnCl4 is an ionic compound because the hint was rule 2. So tin is your metal, chlorine is your non-metal. No, remember how we did ionic bonding, right? So you
Excuse
can,
me, Miss. Miss,
yes?
someone is asking you to repeat.
What am
Miss
I
is going to be
repeating?
4 then.
What am I to repeat at what point? All right, just rewatch the video. All right, so let's look on it, Liz. When we were writing ionic, the formula for ionic compounds, remember that we had, let's say, for example, AB, and the charges were up here, right? What did we do next? We said that
We
we
cross
swap the
multiple
charge, right? So you swap the charges. So in
mm-hmm.
order, when you get an ionic compound, ladies, and you need to figure out what the charge was, you can simply look at the subscripts that are available, right? Look at the subscripts that are there. If there are no subscripts, then you know that it is taken to be 1. And what I like to tell my girls, push back the numbers that were switched. Put them back where they're coming from, and you will find out what the charges are. So let us put back the number for tin and chlorine. So I'm writing back the symbols. What will be the number up here for tin?
4 positive.
4. Very good. And because it is an metal, because it's metal, we know it is a positive charge. What is it that we're gonna have for chlorine?
1 negative.
One. Very good. So because, right, there's no subscript there, we know that it is taken to be 1. Chlorine is a non-metal, and so it is a negative charge. So this is all you're going to do, ladies. My oxidation number, right, is synonymous to the charges. So it's simple. What is my oxidation number 14? All I have
4.
to do
4
is
plus
to,
1.
right, I know it is 4, but to place an emphasis, because oxidation numbers are positive and negative numbers, I'm going to put plus 4. All right. So because the oxidation numbers are negative or positive numbers, to emphasize, I'm going to put the sign there and put plus 4. What would it be for chlorine?
Minus
Miss
one.
minus 1.
Very good.
And it's
Excellent.
undergo reduction, right?
No,
Or
it's not undergoing anything, just, well, if you look at it like a direct combination, then yes. Yes. So oil rig, yes.
Do a next one, miss. Do a next one. Do a next one.
We
I
have
like it.
see the whole paper there, man. We have all of this paper here. All right, so that's the first one. All right,
Miss,
so I
I'm
do
not
I
seeing the other half of the paper. Miss, I want to see what if they put the. Never mind.
okay. All right, I'll take your word for it. All right, ladies. So don't get mad. I'm going to clear the canvas.
Miss, these some of these are just easy to see if I'm just looking at them. Miss, so is
Yes.
it usually called tin 4 chloride?
Yes, and I was about to say it. And then I
Mm,
realized that if I said it, then it would have given you the answer. But they call it tin 4 chloride.
mm.
All right, let's look at this one now. Ca3p2. So we have calcium, right? Phosphide. Rule number two has to do with an ionic compound. So the rule says, again, the oxidation numbers pretty much are the same as the charges for ionic compounds. So we're going to break it up. This is made of calcium and phosphorus. What is the charge on my calcium? Remember I said, if it's ionic, put back the charges. All right, so you're doing the reverse. So what would have been the charge on calcium here?
2.
2 plus. Remember, it's a charge, so you must tell me plus or minus. And for phosphorus, what would have been the charge?
Is 3
2
negative.
negative 2. Oh, 3, negative 3.
Right, so we're putting max. So it is 2 plus 3 minus. So look how easy it is to find the oxidation number. Oxidation numbers are synonymous to
Miss,
my
and this is
ionic charge. Yes?
Miss, and this is only for 100% ionic compound.
Yes. This
Miss,
is
I
for
have a
ionic
question.
compounds. So my oxidation number for calcium would have been plus 2, and for phosphorus would have been minus 3.
Baby, you know,
Miss Beviana asks why is the thing 3 negative? I can answer.
Why is phosphorus?
Yeah, 3
mm,
negative. I can answer the
Sure, go
charge.
ahead.
non-metal.
Okay,
Mm.
the reason why it is 3 negative is because we know that this is an ionic compound, and ionic compounds are made up of a metal and a non-metal bonding. And, or you can say, yeah. So when we know that when to form for them to bond or for us to see the bonding, we um we swap we swap the charges of them. So if phosphorus had 3 as the charge and we swap it, it will be in the subscript of calcium. Likewise, if calcium has 2 at the charge, it would swap and be in the subscript of phosphorus. And we know that it is the bonding of a metal and non-metal, and the metal is usually first, and we know metals are positive and they usually become cations. So
All
they
right. She
so
said,
with
all right, I'm gonna stop you. You're going fine. You are going fine, but
we can
I'm
just
watching the clock, right?
okay.
Now, let me tell you an easier answer. So you're not incorrect, okay? Don't think that. So I'm going to provide you with another response. So the other response is phosphorus is in group 5. Group 5, all of group 5 elements have a -3 charge. That's it. So that is why, again, ladies, when you learn your elements, don't learn them 1, 2, 3, 4, 5. Learn them according to the groups that they're in. So I know that phosphorus is in group 5. The valencies, remember you talk about valencies also, the valency for group 5 is 3. So I know that phosphorus would have a 3 there. It's a non-metal, so it's going to be negative. All
Miss,
right,
that was why I
awesome.
was going to ask a question. Miss, how will we know when they're what if they could use the other valencies that those atoms could have?
That's where
We
we're going now. That is why I cut you short. So let us look at C, right? So C is a very good example because that is where I want to get. So I'm clearing this canvas, ladies. Now let us examine C. So remember, This is the same tin, you know. We had tin already with SnCl4. Now we're looking at tin with SnO. All right, let's see if there's going to be a difference. Now, for this particular one, we're going to look at rules number 4 and 5. It says that the oxidation number of oxygen in the compound is supposed to be -2. So we know we don't have a peroxide there. So right away, we can identify the oxidation number for oxygen, right? And that's because our rule told us so. Now, number 5 said that the oxidation numbers in a compound is supposed to add up to 0. So right now, SNO is a compound, and we know one part of it. So we know what the oxidation number is for oxygen, which is -2. We need to figure it out for tin. Now you might say, but Miss, why do you need to figure it out for tin? We did it already up in A and we found that it was 4. But is it really so? You have to be careful, ladies, with transition metals. It's a reason why they call them transition metals. Transition metals can have different charges. Remember that. So remember we spoke about copper 1 versus copper 2, right? You have others there that they have varying
It's like
charges.
iron and
Iron
phosphorus.
2 and iron 3. Ah, excellent.
And
Iron 2 and
sulfur.
iron 3. So which one is actually taking place in this bond? Right? So tin is one, you know, tin is one such transition metals that can have varying oxidation numbers or varying charges. Now, I know you're good at math, and you can actually look on this and tell what it is just by me identifying rule number 4 by saying that the oxidation number for oxygen is -2. So we're going to do it the long way, and then we're going to look on it being sensible heads and reasoning out, right? So let's look on it based on rule number 5. The sum of the oxidation numbers in a compound is equal to 0. Now we can write this out. So it means that the Sn oxidation number for Sn plus the oxidation number for O should be equal to 0. Sum of the oxidation numbers are equal to 0 in a compound. This is my equation. So the oxidation number 14 plus the oxidation number for oxygen should equal to 0. Now, just like any math equation, usually you have knowns and unknown. Right now, my tin, the oxidation number 14, is a big question mark. We don't know it. That is what we're trying to find out. So I'm going to write it back down here because I don't know it. However, I know the oxidation number for oxygen because the rule tells me that it is -2 in compounds except for in a peroxide. I don't have a peroxide. So I'm going to add the oxidation number for oxygen. Now I need to take into consideration how many atoms do I have of each. I have 1 tin in this case and I have 1 oxygen. So I don't need any multiples here. I write back my equation because it's supposed to be equal to 0. I'm continuing. Oxidation number of tin. I can get rid of these two. You do math, right? So I have plus and minus here. It's the same thing as saying -2 is equal to 0. Other line. Now, you don't have to do all of this, ladies, but I'm showing you is equal to 0. Carry it over, you end up with +2. So what is the oxidation number 14? +2. All right, I'm going to give you a minute to soak that up. And then we're going to look at the formula and use common
Yes,
sense to get this.
yes, yes. Miss, these are so Miss. From when I saw it, I was like, this has to be two Miss, because I usually like, if you know oxygen's
Mm.
charge or whatever, you just see it in your head. But then we did all of this working out. It's like, okay, uh,
All right, so let's go. Now, sometimes I need to work it out. Hope, just to be certain, but let's look on it. If this is -2, ladies, right? It was told to us. So if this is -2 and I have no subscript, remember when you have no subscript, the charges are balanced. When you have no subscript, the charges are balanced. So if I have here -2, then guess what? It must be +2 on this side. So again, there's sometimes, you don't have to do this long calculation to get it.
So excuse me, so
Mhm.
if you have one like this and the other one say minus, never mind. No.
All right. So let's look again, ladies. S and O, there are no subscripts. Once you have no subscripts in your formula, the charges are balanced. So if they give you one and say, okay, for oxygen it is -2, then the obvious balance to a -2 is a +2. So we didn't have to go through all of this. However, there are some instances where you're not that fortunate and you're going to have to work it out. All right, let's look at F. All right, so we're clearing canvas again. Let's look at F. So F is not as straightforward. F now is N2H4. It is not as straightforward, ladies, because now I have subscripts in play. Yes, some of you are quick at math, but let's do it for the others who are not so swift, all right? Now, there is a rule governing hydrogen, so that's good. It tells us that hydrogen is +1 unless it is bonded to a metal. So unless it's in a metal hydride. So for example, sodium hydride, then I know it's going to be otherwise. So I know for right now, this is a compound. So it must add up to 0. The oxidation numbers must add up to 0. I know one part
Miss,
of it.
why
Mhm.
why are we in NH? Aren't we in number D? I mean letter D.
No, we're jumping because you can do these. We explored rule number 2 twice.
Miss, but D
So we're
seems like one
doing,
of those. D seems like one of those that
no
it's not
man,
going to be
these
affected.
anic, these anic.
But isn't sulfur usually 4? But if you carry it over, you'd see like a
These
2.
anic, these anic. You can easily find D.
Okay.
So that's why we're jumping to F. We need to explore. We haven't done 5, rule number 3 and 5 together. So we're jumping. All right, so let's go again now, ladies. So we are exploring now. So this is a compound, that's fact number 1. 2, it has hydrogen in it and it's not bonded to a metal. So we know that the oxidation number of hydrogen is going to be +1. Now, in this case, we need to take into consideration how many atoms are present. So we know that you must have the oxidation number of nitrogen plus the oxidation number of oxygen, and this is going to be equal to 0. But there's a special case here. We have more than one nitrogen. So how many do we have? 2. So it's twice the number.
Miss, you confused me for a second there.
Why?
Miss, oh, oxygen reaching. Miss is not hydrogen.
Oh, hydrogen. So when you say I'm confused, just tell me that this is an error.
Oh,
That but they said to
It's not confused, just an error. Because I was talking about oxygen so much. All right, so my apologies. Thank you. So hydrogen, hydrogen. All right, so it is 4 times the number of hydrogen atoms. All right, now our question mark here is nitrogen. We know hydrogen. So it is now 2. All right, so may I call this X, ladies? May I call it X for simplicity?
yes, miss.
All right. So what we have here now is 2x plus 4 times 1. All right. Our next line there will be 2x plus 4. All right. How do we solve for x?
Divide both sides by
By
2.
2.
Very good. So we end up with minus 4 divided by 2. So x is now equal to minus
Minus 2.
2. And that's the answer.
Miss, so that means that nitrogen, Mrs. Nitrogen
Mm-hmm.
is, Miss, what is it again? The N.
Nitrogen, you're correct.
Oh, Miss, that would be -4. That would be the oxidation number.
For nitrogen,
Yes,
Yes.
no man. Nitrogen's oxidation number is -2 in this case. It is just that now you have 2 atoms of them. So one nitrogen will be -2, the other nitrogen will be -2. So the 2 here is subscript 2. So each will have a -2.
So means
Mhm.
means it because this is not a compound now we don't switch it, we just swap them.
This is not ionic. It's not
Oh.
ionic, right? Only for ionic compounds.
Miss, this is covalent.
Yeah, man. Nitrogen and hydrogen, 2 nonmetals. Yes, 2 nonmetals. All right. Do we have time? All right. Quick one.
Miss, I'm confused. I lost.
You're not. No, you're not. J. What would be the oxidation number for oxygen? Quick, quick.
-2.
-2.
Nope.
Negative. What?
Look on it.
-4.
All right. Rule number 1. What does it say? Pure elements or uncombined elements have an oxidation
0.
number of 0. Very
Actually, I
good.
tell us the oxygen and
I
negative.
know. So you have to be careful. Oxygen in a compound has -2. Oxygen molecule or oxygen, just the element, is 0.
Miss, that trick my body now. It not do me that.
I know. That's why I just draw for it a while ago. So you have to think it through, ladies. All right. So you're going to get a copy of this and you are going to practice for Friday's class. All right. Because we
Miss,
need to tackle these 3 here. When you have polyatomic ions, how do we
miss,
treat them? Yes, darling?
miss, I know how to do the potassium MnO1.
4.
Miss,
Oh,
I know,
awesome.
miss, I know how to do, miss, I know how to do them.